breeding these plants together. Some guy named Monk crossbred plants. And they're purple and white flowers, and what he got when he crossbred these plants was 534 plants which had white flowers and 320 plants which had purple flowers. How? What? Yeah. Find the experimental probability that a plant had each type of flower. So, what is a critical factor that you need to know? I do need to know the color and type of flowers, sure, and how many were in each of those groups, but they gave that to me. What else do I need to know? He's got them all, yes. Oh, no, they're different plants. They're separate plants. How do you find probabilities? You guys told me for the dye it was 1 out of 6. Okay, now where did you get the number 854? I don't know. You said something like 1. Oh, okay. I thought you meant like one giant plant. I was confused. Okay. It is important that we find the total numbers so that we can do what? Well, what's the plants that had white flowers? What's the probability there? We had 534 that had the white flowers, and 854 total. Divide what by 534?
854.
So you want 854 divided by 534. That's more than 100%. Yeah, that's not going to work. That ain't it, Chief. Let's try again.
Would you divide it by?
No. Come on the number die, you told me there was 1 5 and a total of 6 sides.
Thanks for England.
No, next. 1 5 and 6 sides. So you knew the total number of sides was 6, and you knew that the successful one that I was looking for, there was only one of those.
Is it 1 over 854?
No, we've got more than one white flowering plant out of 854. Oh, there you go. 534.
Oh, you just told us we were close. Like you said close, but no cigar. So,
well, hey, I just figured you'd flip it over and be right. Hey, I need you to think. That's the whole point. Okay, folks, I do not need you to reduce the fraction. I don't even care if you change it to a decimal. If you feel like you need to change it to a decimal, I'm okay. What was the question?
Oh, I was going to answer.
Okay, so tell me the next one.
Would it be 320 over 854?
That is exactly right. 320 over 854. Hopefully you got it written down. Move it out?
Yeah.
Yep.
You're right, Nick.
I'm not going to. I don't realize that.
Okay, we're done with that?
Yeah.
Let's move on to question 3.
So you don't need us to reduce this?
No.
Talking a lot of sweat for somebody who's still in high school. But
Yeah, I'm still here.
No,
when your mom's picking you up?
Got him. All right, now, question 3.
No, my mom's still in the kitchen.
Okay, come on. I don't know. I really don't. I don't know why half the discussion's happening here, including ones up there. Now, I need to know what in order to figure out these experimental probabilities. Let's just figure out for the rolling a 2. How many times they rolled it. So you need to figure out how many times they rolled it. Use your machine. Figure out, let's get one person over here, Mr. DeWald, and then we'll have Mr. Mr. Bola, check it out on the other side. We'll see if they get the same answer. I need the number of total occurrences. They rolled the die. Come on. Start adding.
Oh, it's like,
Yeah, I got 308 from Mr. DeWall. Does anybody else got a 308?
I got
308. Okay, so we know that the denominator is 308. So how do I find the experimental probability of rolling a 2?
plug in the occurrences over. It's pretty close.
49 over 308 is your answer for that. No, I'm not going to go through that whole chart. I think it's pretty easy to do.
Yep, it's pretty close.
Yeah,
You just want us to give them fractions.
correct. The fraction will be fine. Okay. Question 4. A marble is selected at random from a jar containing 30 marbles, or 30 red, 10 yellow, 60 green. Find the theoretical probability that it is either red or green. Theoretical probability that it's red or green.
Because it's 10 out of 90. No, because you have to add the.
How many total do we have?
100.
We have 100 total, right?
So you have.
And how many of them are in this group right here, red or green? That's 90, right?
So you have 90%.
So we have either, you can write 90 over 100, you can write 9 over 10, you can write 0.9, you can write 90%. Any one of those answers is going to get you full credit.
I thought you said either red or green, so I just.
Oh, no, red or green. Okay, now, why was it easy for you to tell that?
Because add them to be 100.
Well, we knew the total was 100, but this is a really important point. You cannot have a marble which is both red and green at the same time. In this particular example, they're either red or they're yellow or they're green, but there's no marble that is both at the same time. Now, I'm not going to do a lot with this, but have you ever heard the term Venn diagrams? Okay, now, there's two different diagrams that I'm going to draw, and I want you to tell me which one question 4 was in. Do you think that's the picture of number 4, or do you think this is the picture for question 4? The one on the left, does it look like there is something in common between the circles or nothing in common? They overlap, so there is something in common. But 4 didn't have that, so this is the picture that goes with that situation. It's also the same type of picture that fathers want for their daughters when it comes to things like prom, you know, and those dances, you know. The term that is seen here is called mutually exclusive. Mutually exclusive. They do not overlap or touch at all. That's why the dads want that way.
Most girls' dads want that.
Mm-hmm.
No, my dad said you're 18, you can do whatever you want, just don't get in trouble.
That's what my dad says too.
Like, you're responsible
Just
enough.
don't go to prison. Yes. Okay.
She can go to prison.
You gotta
Start calling you
I'll let you
Blanche.
sit there. Let's just say it.
Let me see if there's a different one besides. And then you can tell me what you were going to tell me in a minute. Okay, a group of 40 students from your school is part of the audience for a TV game show. The total number of people in the audience is 150. What is the theoretical probability of 4 students from your school being selected as contestants out of 8 possible contestant spots? Interesting. A group of 40 students, come on, from your school is part of a TV audience. The total number of people in the audience is 150. Okay, now this is a decently complicated question. I will tell you that this involves groups of students. So groups of students would be what? Permutations or combinations? Combinations. Okay? Not sure I would put this particular question on a quiz or test, okay? Because it's a little bit more challenging. Now remember in our other examples how we were dividing by a total, right? So we're going to have to find the total number of groups. This will be our last question of the day. Okay? The total number of groups that you could choose, out of the 150 different people, we're choosing groups of 8. Some of those groups have kids from our school, and some of those groups have none of the kids from our school. But this is the total number of groups. Okay? Now, we're going to split up the numerator into 2 parts. These are kids from my school, and these are other kids.
Just a reminder, there is after-school detention
Okay.
and community service. If you've been assigned to one, be responsible.
Stay with me. I've got this last example I want to finish. Okay, shut up. Shut up. Thank you. Okay. We have 40 kids in my school, and they want to know the probability that 4 of them will get picked. Okay, now, how many kids in this audience are not from my school? 110, right? If they've picked, let's just suppose they pick 4 kids and they happen to all be from my school. How many kids are they going to pick from all the other kids? 4. Because they need a total of 8 kids. That's why this question would be more difficult to figure out. This isn't a matter of just counting and dividing. You have to find the groups for 40C4, the groups for 110C4, multiply those together, and then divide by the groups of 150C8. That's a tougher question, and I probably won't throw that on your quiz or test. Let me type it on my machine, and I'll figure that out for you. 40.
Did you check notes?
While I was walking around the room. Now, you can lose that privilege on the music. So please respect me when it comes to using the technology. So the numerator's massive and the denominator.
See you tomorrow, Mr. Steve.
We'll see you. It's 10%. 10%. You did it? Oh, good. And that was equal to 10%, 0.1. Yes.